Hey scholars, I hope this video finds you well, and I hope that you've had a great start back to this semester. In the last lesson, we discussed how to add and subtract rational expressions with the same denominator, or like denominators, but now we'll cover how to add and subtract them when they have different denominators. So make sure you're paying close attention and taking good notes. It might seem a little tricky at first, but you'll get it down with enough practice. Just hang in there. Let's go ahead and get going. So remember, in the last lesson we added and subtracted rational expressions that had the same denominator. But in this lesson we're going to add and subtract them when they have different denominators. And remember, rational expressions behave like fractions. So let's just look at some basic fractions, and the way we're going to add these is going to be the same way we're going to add rational expressions. Okay? So what I'm going to talk about here is going to really connect and maybe help, hopefully, with what we see later in this lesson. So let's add 1/3 plus 1/4. So the first thing I notice about these fractions is that they have different denominators. And in order to add and subtract fractions, we need them to have the same denominator. So we need to convert these in a way that makes them have the same denominator. So what I'm going to do is I'm going to look at the least common multiple of 3 and 4, the least common multiple of the denominators, which we can also call the least common denominator, the LCD. Okay? So one trick you can use to find the least common multiple when at least one of these numbers is prime, so 3 is a prime number but 4 is not, you could just simply multiply them together. We could say 3 times 4, that's going to be 12. So the least common multiple of the denominators is 12, or like I said, the least common denominator is 12. Now, just real quick, if this was 1/6 and we said 6 times 4, well, both of those are not prime. Okay, they're composite numbers. 6 times 4 is 24, but 6 times 2 is 12, and 4 times 3 is 12. So really, if it was 6 and 4, their least common denominator would also be 12. So just want to say that because we don't necessarily always just multiply those denominators to get the least common denominator. Only when at least one of them is prime. So anyway, now that I have found the least common denominator, I want to write each of these fractions with that denominator of 12. So something over 12 plus something over 12. Well, 3 times 4 is 12. So that means we have to say 1 times 4 is 12. Because really what we're saying is we're multiplying 1/3 times 4 over 4. Well, 4 over 4 is 1, right? So we're not actually changing that number. If we say 1/3 times 1, that's 1/3. But we're just converting it in a way that makes it easy to work with. So that's going to change to 4/12. And then we know that 4 times 3 is 12. So that means we also have to multiply the numerator 1 times 3. So 1 times 3 is 3. So now we have 4/12 plus 3/12, and that'll give us 7/12. So that's how you add fractions. When we add rational expressions, it will work the same way. So hopefully you're able to make that connection when we practice adding and subtracting rational expressions. So before we start adding and subtracting rational expressions, a skill that we need to get down is to be able to find the LCM of polynomials. Go ahead and write these down. You should have your slides out, and so you can copy these from your slides or from this video. And there are 2 steps to finding the least common multiple of polynomials. You should factor each polynomial completely. Write any repeated factors as powers. So here's an example. X cubed plus 6x squared plus 9x. Well, you'd factor out the x first, and then you can factor out this trinomial, this quadratic trinomial, x squared plus 6x plus 9. So that's going to factor out as x times x plus 3 times x plus 3, which can then be rewritten as x times x plus 3 squared, because x plus 3 was listed out twice. Okay? So it says to write any repeated factors as powers. So we just wrote the repeated x plus 3 as x plus 3 squared. All right, number 2 says to list the different factors. If the polynomials have common factors, we are going to use the highest power of each common factor. Now, these may not make a ton of sense to you now, but we're going to apply those here in a second. And here are some examples for you to look at. You can look at those on your slides and after we work a couple examples together. All right, so This skill is going to help us when we finally end up adding and subtracting rational expressions. So let's look at these terms. Okay, so here we have two monomials. All right, we're trying to find the LCM of these monomials. All right, so we have 4x cubed y to the 7th and 3x to the 5th times or 3x to the 5th y to the 4th. Okay, so let's look at 4 and 3. All right, these are the two just integer numbers. So we have 4 and 3. Their least common multiple is 12. Well, now we see that they both have an x, a variable of x. Now the highest exponent of x is 5. All right, so 5 is greater than 3. So when we list out the least common multiple, we're going to go with the highest exponent. So we're going to say x, and then we're going to go with the highest exponent, which is 5. Well, then for y, we have y to the 7th and y to the 4th. Remember, we're going to go with the highest exponent of y. So we'll go with y to the 7th because it's the highest exponent. So the least common multiple of 4x cubed y to the 7th and 3x to the 5th and y to the 4th is 12 x to the 5th y to the 7th. Okay? All right. So now let's look at the second one. Here we have two terms. We have a quadratic binomial and then a quadratic trinomial. So what we're going to need to do is factor these. We didn't have to factor on number 1, but on these we need to factor. Well, x squared minus 4, that's a difference of squares. That factors out to x plus 2 times x minus 2. And then we have x squared plus 5x plus 6. Well, what factors of 6 add up to 5? Well, that'll factor, let me do this. That'll factor as x plus 2 times x plus 3. All right. Well, now when we're writing out their LCM, we see that they have a common factor. X plus 2 is a common factor. Now, remember we saw that they had a common, on number 1, they had a common factor of x, but we went with the highest exponent, okay? But for x plus 2 here, they both have an exponent of 1. So we can just say x plus 2. We can just write that one time, all right? The exponent is 1, which we don't need to write. All right, but now we see two different factors, x minus 2 and x plus 3. Okay, so these different factors, the ones they don't have in common, we have to write each of those. So I'm going to write x minus 2 and then x plus 3. Okay, so now the least common multiple of x squared minus 4 and x squared plus 5x plus 6 is x plus 2 times x minus 2 times x plus 3. Maybe rewind that if you didn't catch on there. And I did not distribute that out. I could, technically, but there's really no need to. We won't do that. I will not force you to do that. All right. Now let's look at a last example. X squared plus 4x plus 4, that's a quadratic trinomial. And then we have x squared minus 4, quadratic binomial. Same one we saw over here. So x squared plus 4x plus 4, that's going to factor as x plus 2 times x plus 2. And remember, it told us to write repeated factors with an exponent, okay? So instead of x plus 2 times x plus 2, I'm going to say x plus 2 squared. All right. And so x squared minus 4, that's going to factor as x plus 2, x minus 2. X plus 2 times x minus 2. All right. So now we see x plus 2 in both of these, just like we did on number 2. However, the difference here is that this one has a power of 2. That x plus 2 has a power of 2, and this x plus 2 has a power of 1. So we need to go with the highest exponent here, which was 2. So when we write our least common multiple, we're going to say x plus 2, not to the first power, but to the second power. We go with the highest power. Now, this binomial has a factor of x minus 2, while this one does not. Okay? So in the LCM, I have to include x minus 2 as well. Okay? And then here is the LCM. X plus 2 squared times x minus 2. Okay? Now, knowing this skill is going to help us when we add and subtract. Alright, so this is what this has all been leading up to, adding and subtracting rational expressions with unlike denominators. Here's an example that you might want to look at after I run through a couple examples here. So now let's simplify these. We have 6 over x minus 1 minus 5x over 4. Alright, so first thing we should notice is that these have different denominators. Now remember earlier when we had 1/3 plus 1/4, 3 was prime, right? So I could just simply say 3 times 4 was 12 and get that would give me the least common denominator. Well, 4 is not a prime number, but x minus 1, we cannot factor that any further, so we can just treat that as if it is a prime number, since we cannot factor it. So we can say the least common denominator, or the least common multiple of the denominators, would be 4 times x minus 1, or x minus 1 times 4. I prefer to write as 4 times x minus 1. Alright, so we want both of these denominators to be 4 times x minus 1. So in order to get that least common denominator, what do I need to multiply x minus 1 by to get 4 times x minus 1? Well, obviously, you need to multiply it by 4. Now, remember, if we multiply the denominator by a number, we also have to multiply the numerator by that same number. Because 4 over 4 is 1. We're not actually changing the nature of the number, just the way it looks, just its form. Okay? So I will distribute all that in a second. Let's look at the second term, 5x over 4. Well, how am I going to get the least common denominator? How am I going to go from 4 to 4 times x minus 1? Well, we just need to multiply by x minus 1 on the denominator and numerator. Okay, so now we can see that this denominator is 4 times x minus 1 and this denominator is 4 times x minus 1. Now they have the same denominator. So at this point, we just need to distribute. So I'm going to say 4 times 6, that is 24. And I'm actually not going to distribute the denominator. We don't have to do that. That's an unnecessary step. We can just leave it as that LCD. We can just leave it as 4 times x minus 1. So now I'm just going to put minus. And then we're going to say 5x times x is 5x squared. And then 5x times negative 1 is negative 5x. And then I'm going to write that common denominator. 4 times x minus 1. Now my next step is to distribute the minus sign. So we're going to get 24 minus 5x squared plus 5x. And then what we can do is write it all on the same denominator. We can put that all in the same numerator, and then it's all over the same denominator. And then your last step can be to just write it in standard form. You say equals negative 5x squared plus 5x plus 24 all over 4 over x minus 1. Now, I know that might have seemed tough, but go ahead and rewind it if you need to review that. Alright, so now let's look at the second problem. It's going to be a little bit different. In this case, we're going to need to factor this denominator first. Okay? So I'm going to say 2x squared minus 16, and then we know that the denominator is x squared minus 4, which factors as x plus 2 times x minus 2. And then we're going to say minus x plus 4 over x plus 2. Now we need to find the least common multiple of these denominators, or the least common denominator, right? So we see that they both have x plus 2, but this one has x minus 2 and this one doesn't. So in order to make them have the same denominator, I'm going to write x minus 2, I'm going to multiply that denominator by x minus 2, and I'm going to multiply this numerator by x minus 2. Okay, so I'm going to just say 2x squared minus 16 over x plus 2 times x minus 2. And then I'm going to go ahead and just distribute these out. I'm going to say minus And that's going to, when I distribute these, that's going to give me x squared plus 4x minus 2x. That's going to give me plus 2x. 4 times negative 2 is negative 8. I'm going to, I'll leave that. And then I'm going to keep that same denominator. X plus 2 times x minus 2. All right. Now, I can distribute this negative and put them all on the same line. So we're going to get, it's going to equal 2x squared minus 16 minus x squared minus 2x plus 8 all over x plus 2 times x minus 2. Now at this point I'm just going to combine like terms in the numerator. So 2x squared minus x squared, well that's going to give me x squared. I'm just going to write the final answer up here. 2x squared minus x squared is x squared. And then the next term, I'm going to put this in standard form, so I'm going to look at negative 2x. So minus 2x, there were no like terms for that. And then negative 16 plus 8 is minus 8 over x plus 2 times x minus 2. Now, let's check this out. I can actually go one step further. I can factor x squared minus 2x minus 8. And that's going to factor as x minus 4 times x plus 2 over x plus 2 times x minus 2. Well, these x plus 2's, we have one in the denominator and one in the numerator. They will cancel. And that will leave us with x minus 4 over x minus 2. There's our final answer. All of that led us to that answer. Way to hang in there to these rational expressions. So I hope this video was helpful for you. I know that it might have felt like a lot, but I highly encourage you, like I mentioned earlier, to re-watch certain parts, or maybe look through those slides and look through those examples that have been posted on there. But we'll get some practice in our next class. Come with questions and ready to learn and work. Good work today. Thank you, collegiate scholars.